In this network of resistances, we have to calculate what is the potential difference between this 15 ohm resistance. What is the way of calculating potential difference between this 15 ohm resistance? The way is that we have to first calculate what is the equivalent resistance of this network of resistances. Then we have to calculate what is the total current. Then we have to calculate what is the current passing through this and through this line. When we have got what is the current passing through this 15 ohm resistance, we will just apply the Ohm's law, that is V is equal to IR, and we will have what is the voltage or the potential difference between this 15 ohm resistance. Let us start. Here there is two 4 ohm resistances. These are in parallel, so the equivalent resistance is equal to 2 ohm. That is in series with 2 ohm resistances. We are having 15 and 10 ohm resistance in parallel. The equivalent resistance between these 2 points is equal to 6 ohm. Let us calculate here. The R equivalent, this R will be equal to 4 divided by 2, that is 2 ohm. This is in series with 2 ohm, in series with another 2 ohm. We are having 15 and 10 ohm in parallels. Equivalent resistance R is equal to product 15 into 10 divided by sum 15 plus 10, that is 150 divided by 25, that is equal to 6 ohm. So 6 ohm. So this network of resistance in the upper branch is equal to series resistance of 2 ohm, 2 ohm and 6 ohm. So the net resistance of the upper branch is equal to 10 ohm. Similarly, 2, 8 and 8 ohm resistances, that is equivalent resistance 8 by 2, that is 4 ohm. 12 and 12, 12 divided by 2, that is 6 ohm. So we have 4 ohm and 6 ohm resistances, 6 ohm resistances in series. The equivalent resistance is equal to 10 ohm. So we are having a 10 ohm branch, upper branch, lower branch, 10 ohm in series with 1 ohm resistance and connected to a 12 volt supply. The equivalent resistance of the circuit, that is 10 divided by 2, that is 5. 5 plus 1 is 6, because these two are in parallel. So equivalent resistance is 10 divided by 2, that is 5 ohm. And in series with 1 ohm resistance, the equivalent resistance is 5 plus 1 is equal to 6. So we are having a 12 volt supply connected to a 6 ohm resistance. Now the total current I is equal to 12 divided by 6, that is equal to 2 ampere. We are having current of 2 ampere flowing in the circuit. When the current of 2 ampere flows in a circuit, when it reaches this point, we are having two 10 ohm resistances in parallels. 10 ohm equivalent resistance of this branch, 10 ohm equivalent resistance of this branch. So the current divides equally, or the current distributes equally. So when we have an equal distribution of 2 ampere current, so we are having 1 ampere current through this branch and 1 ampere current through this branch. Now we are having 0.5 through this and 0.5 through this, and here it adds to 1 ampere. Now we have to calculate here how 1 ampere of current distributes through this branch. By current dividers rule, we are aware about the current flowing through this resistance is equal to I will be equal to total current, that is 1 ampere, into opposite resistance, that is 10, divided by sum of resistance, that is 10 plus 15. So I we are having, that is 1 into 10 divided by 25. So we are having I will be equal to 0.4 ampere. So out of 1 ampere, 0.4 ampere flows through this 15 ohm resistance, and the rest 0.6 ampere flows through 10 ohm resistance. So what we are doing to calculate, or what is the potential difference between this point and this point through 15 ohm resistor, that is V15 will be equal to 0.4 into 15. 0.4 into 15 is equal to 6 volts. So the net voltage, or the potential difference between these 2 points, or 15 ohm resistance, is equal to 6 volt. We will cross check it. As this resistance and this resistance are in parallel, so the potential difference between this point and this point should be same as that between 10 ohm resistor. We will calculate the potential difference across 10 ohm resistor. So V10 will be equal, what is the current? 0.6, 10, 0.6 into 10 is equal to 6 volts. So by calculating the current that is passing through these two resistances, we are able to see that the potential difference between these two resistors, 15 ohm and 10 ohm, which are in parallel combination, is the same, that is equal to 6 volts.